Good morning, guys. Sorry I'm not there today, um, but hopefully this will help you. I think you'll be fine. Today I want to take a look at the slopes of the lines we've been looking at and specifically look at parallel and perpendicular lines. So if you look here, these two lines are parallel. They will never touch no matter how far they go on and on. If you look at this blue line, it's 1/2 x plus 5. The slope is 1/2. So at every point, we can go up 1 over 2. Up 1 over 2. That is the slope of that line. The other line is 1/2 x plus 1. This slope is also a half. Any point on the line, you go up 1 over 2, and you're at the next point. These are parallel because they have the same slope. All parallel lines have the same slope. All vertical lines are also parallel. They don't technically have a slope, but all vertical lines are parallel because they all have undefined slopes. So in your packet, follow along as I'm doing these. At some point, we're going to pause, and you guys are going to try a few, and then we'll come back and see how you did. Once we're done with the instruction part of this, you have an activity to do. So let's look at line 1. We have to identify which lines are parallel. So line 1 is in slope-intercept form, y equals mx plus b, so I know my slope is 4/3. Line 2 is y equals 2. If you do not remember which kind of line that is, I would make a simple table. It says y equals 2, so the 2 will always be in my y column. And I can put any numbers here. And if I think about this graph, it's 0, 2, 1, 2, 2, 2. So this is a horizontal line, and it has a slope of 0. Line 3 has a slope of 4/3 because it's in y equals mx plus b. And line 4, just as line 2, is a horizontal line that goes through -3 right here. So this also has a slope of 0. So if we were asked to identify which lines are parallel, we would say that line 1 and 3 are parallel because they both have a slope of 4/3. Line 2 and 4 are also parallel because they both have a slope of 0. All right, let's look at another set. Excuse me. The first slope is 5. The second one, y equals x. So we know there's a 1 in front of there. The coefficient of the x is the slope, so this has a slope of 1. Line 3 also has a slope of 5/3. And line 4 in front of the x is the slope, the coefficient, which is also 1. So once again, line 1 and line 3 are parallel because they have the same slope. And line 2 and line 4 are parallel because they have the same slope. Now, in order to write this, if we want to write this mathematically, we could say that 1, I'm going to make it look like a real 1 here. 1 is parallel to 3, and 2 is parallel to 4. These two lines represent parallel in math. Okay, so we have C and D. I want you to pause the video right now. Let you guys try C and D, find the slopes of each one, and then identify which ones are parallel. Then we'll come back and we'll check if your answers are correct. All right, hopefully you're done. Let's look at line 1. Here we have a slope of 2. Y equals mx plus b. Line 2's slope is a -2/3. Now, line 3, we cannot see the slope here. We need to change this into slope-intercept form. So that means we're going to get y by itself. We're going to subtract 2x from both sides. So we have 3y equals -2x plus 8. And then we're going to divide everything by 3. So now my equation will say y equals negative 2/3 x plus 8/3. So my slope here is negative 2/3. Line 4, we could change this into slope-intercept form, but we also have a point slope form that we know, which is y minus y1 equals m times x minus x1. So here is your m, or your slope, so we know the slope is 3. So out of these 4 lines, the only 2 that were parallel were lines 2 and 3. Okay, let's check how we did on D. So D, we have a slope of 3/4. Line 1, I'm sorry. Line 2, again, we need to change this. We have to add 3x to both sides. So I have 4y equals 3x plus 32. We're going to divide everything by 4. And we have y equals 3/4 x plus 8. So my slope is 3/4. Line 3 has a slope of 3. And line 4, there's my slope there in point slope form, so it also has a slope of 3. So we can see that lines 1 and 2 are parallel, and we can see that 3 and 4 are parallel because they have the same slope. Sometimes we have to apply this to geometry. You're going to be doing a lot of this next year. It says show that ABCD is a parallelogram. So we have to use mathematical knowledge that we have to sort of prove. So when we think of a parallelogram, we have to say what makes a parallelogram a parallelogram. And basically, it's saying that opposite sides are parallel. So if we can show that the opposite sides are parallel, then we can prove that this is a parallelogram. So let's look at the slope of AB here. We could just take these 2 points. We could use the slope formula. I'm just going to take the shortcut and say I'm going to rise 2 and run 1, 2, 3, 4, 5. So I rose 2 and I ran 5. The slope of CD, I'm going to rise 2, run 1, 2, 3, 4, 5. So I know that the opposite sides of AB and CD are parallel. We know that the other 2 lines are vertical lines. So these are parallel because they have the same slope. AD and BC are parallel because they're both vertical. So all vertical lines are parallel. Therefore, ABCD is a parallelogram because both pairs of opposite sides are parallel. That's just a little application. Now let's talk about perpendicular lines. A perpendicular line is a line, 2 lines that cross that form a right angle. So any 2 lines that cross that form a right angle are perpendicular lines. So let's take a look at this example right here. The red line here says y is equal to negative 2/3 x plus 3. So that slope is negative 2/3. The blue line says y equals 3/2 x minus 2. So that slope is 3/2. And hopefully you can see that there are some similarities here. This is 2/3 and this is 3/2. So this one is a reciprocal of the other one. And this one is negative and this one is positive. So what we say is that these are negative reciprocals. And basically a negative reciprocal means that the slopes have to have different signs and they have to be reciprocals of each other. And it is understood that all horizontal and vertical lines are perpendicular. We don't need to really look at the slopes. However, if you did, you could say that this was a slope of 0, let's say 0 over 1, where this would be like 1 over 0. But we don't even think about that. We really just know that horizontal and vertical lines are perpendicular. So if we look down here, y equals 3. That is this line right here. So this is a horizontal line. X equals -2. This would be right here. X equals -2. So that is a vertical line. So I know that line 1 and line 2 are perpendicular. And the way we write that is this. Line 1 is perpendicular to line 2. Now, if we look at 3 and 4, the slope of line 3 is 3, and the slope of line 4 is -1/3. So this one is positive, this one is negative, check. This one is 3 over 1, this one is 1 over 3, check. These are negative reciprocals of each other, so 3 is perpendicular to 4. I know that's a little more detailed than the parallel. Parallel is definitely easier. It's just the same slope, but we will go over a few more of these. So let's look at 3b. We have to identify which ones are perpendicular. Remember, they are negative reciprocals of each other. So y equals -4 is a horizontal line. Here, line 2, we have a slope of 5. That's in point slope form. Line 3, x equals 3, is a vertical line. And line 4, my slope is right here at -1/5. So I have a horizontal and a vertical line, so I automatically know that 1 and 3 are perpendicular. If I wanted to make 5 a fraction, I would put it over 1. 5 over 1 is the reciprocal of 1 over 5. This is positive, this is negative, so these are negative reciprocals of each other. So 2 is perpendicular to 4. All right, let's do... Why don't you pause here? You can try these, and then we will come back and see if you got the right answer. Okay, so the slope of line 1 is 3. The slope of line 2 is -1/3. The slope of y equals 0. That's a horizontal line, so it's a 0 slope. And x equals 6 is a vertical line. So I automatically know that 3 is perpendicular to 4 because it's a horizontal and a vertical. Here, I have 3 over 1 and 1 over 3, positive and negative. These are negative reciprocals of each other, so you should have 1 is perpendicular to 2. All right, so we're going to just take this information and we're going to move it one step further before you do your activity. Here we have to write an equation in slope-intercept form for the line that passes through 4 or 5 and is parallel to the line described by y equals 5x plus 10. So I have to make a new equation, and the only thing I know is that this point is on the new line, and I know that it's parallel to this. Being parallel to this is a key component because I know that this slope is 5. So my new slope is also going to be 5. I also know that the point 4, 5 lies on that line. So that's an x coordinate and that's a y coordinate. So if I think about point slope form, y minus y1 equals m times x minus x1, I could plug these 3 pieces of information in and get an equation. So I have y minus 5, that's my y, equals, my slope is going to be 5 because it's parallel to this, x minus, here's my x value of 4. Now, this is an equation of a line, except it asks for slope-intercept form. So we can easily convert this to slope-intercept form. If I distribute the 5, I would have 5x minus 20, add 5, and I have y equals 5x minus 15. So this is parallel to that line, and it includes the 0.45. So that's the equation of the new line. And let's try one with perpendicular. So it says write an equation in slope-intercept form for the line that passes through 3, 2 and is perpendicular to the line described here. So if it is perpendicular, this slope is 3 or 3 over 1. So my perpendicular slope will be negative because this is positive. And instead of 3 over 1, this will be 1/3. I also have a 0.32, which is my x and my y. So filling in point slope form, y minus y1, which is 2, equals the slope negative 1/3 times x minus x1, which is 3. Now, I know some of you are probably grumbling about the fraction. You will live, I promise. Y minus 2. So if we're going to distribute negative 1/3, I would have negative 1/3 x. Now here's a negative times a negative, this next part. So that's going to be a positive. And 1/3 times 3, or 3 over 1, just gives me a positive 1. And my last step is to add 2. So my equation is y equals negative 1/3 x plus 3. So here I created a new line that was parallel with the same slope and using this point. And here I came up with a perpendicular line because I took the slope of this one and made my new slope the negative reciprocal. So why don't you pause right here? You're going to try these two. You can help your neighbor if they need help. And then when you have finished these two, let's come back, check our answers, and then we'll be ready for our activity. Okay, hopefully that wasn't so bad. The first one says write an equation in slope-intercept form for the line that passes through 5, 7 and is parallel to this line. So this slope is a 4/5. So my new slope will also be 4/5 because they are parallel. And I have the 0.57. So I use my point slope form. Y minus y1 is y minus 7. My slope is 4/5. And my x value is 5, so it would be x minus 5. Again, we have to distribute this fraction, 4/5 x. 4/5 times negative 5 is going to be a negative number. If we put this over 1, those 5s would cancel out, and we're just left with a 4. Last step, add your 7, and y equals 4/5 x plus 3. And last but not least, now we're going to form a line that is perpendicular. The slope of this line is 5. So my new slope is going to be negative because this one is positive. This is 5 over 1, so this is going to be 1 over 5. The point that we're plugging in is negative 5, 3. So there's an x and a y. So I plug in my values in point slope form. Y minus 3 equals negative 1/5 x minus negative 5. So we have y minus 3 equals negative 1/5 times x plus 5 because subtracting a negative is like adding the opposite. Now we're going to distribute negative 1/5, I'm sorry. So here I'll have negative 1/5 x. And when I distribute it here, it will be a negative, and these 5s cancel out, so I have a negative 1. Last step, add a 3. And my final equation is y equals negative 1/5 x plus 2. So that is what you're going to be doing in this activity. You're going to be doing a Mathlib. You're going to work in groups of no more than 3. If you have enough Chromebooks and you want to work alone, that's fine. You're going to go to Google Classroom. I have posted the parallel and perpendicular math lab activity there. Instead of using cards, you're just going to use the Google slide presentation to see what the questions are. You'll be given a recording sheet, and on the back of the recording sheet is where you put the words that match the answers on the cards. If there's any questions, do not worry. I can answer them tomorrow. Have a great day, and I will see you later.